So dear student, welcome to the class. So you can see the question on the screen. So this question is related to work energy method. So now let me read the question. A block weighing 250 Newton, it rests on a horizontal plane. Okay, so let me draw one horizontal plane. Okay, and the weight of 250 Newton. It is acted on the horizontal surface, and the coefficient of friction between the surface and the weight, that is given as mu 0.2 is the coefficient of friction. Now this block is pulled by a force of 100 Newton acting at an angle of 30 degree to the horizontal. Okay, so to the horizontal, this is the horizontal plane. So there is a one force which is pulled by a 1000 Newton. So let me find the center of this object, and this object, it is pulled by a load of 1000 Newton at an angle. First let me draw the angle here. So that angle is 30 degree. Okay, now this force, it is pulled. Okay, it means the direction, you can write 1000 Newton. Okay, so from the center. Now find the velocity of the block after it moves 30 meter from the rest. So if this body, it moves at a distance of 30 meter. So this is the displacement of the object from the rest. Okay, so that you have to calculate. First you need to calculate the velocity of the body when it moves a distance of that, let me say S is the displacement, that is 30 meter. So that you have to calculate. And second, if the force 1000 Newton is removed, if this force is removed, okay, then how much further it will move? When this force is removed, so what will be the distance? Means from the initial, what will be the final distance? Means when the load is removed, so how much it can take the displacement, that you have to calculate using the work energy method. Okay, when the load is acting, so what are the velocity that you have to calculate, right? So let me start this problem. So first, before solving the problem, you have to construct a free body diagram first. Okay, now this is the weight, it is given as 2500. So the force is nothing but it is acting downward. The weight of the body, it will be act downward. So that is 2500 Newton, and 1000 Newton acting at 30 degree, and there will be a reaction force that will be acting upward, that is N. You can represent here also, and load in downward. There is no changes in the diagram. Okay, and if this is the force which is applied towards the right side, so there will be a friction force towards the left side opposite to the applied force, that is friction force. F is equal to mu into N is the friction force. Okay, so now you can go for solving the problems. So first case we will solve when we will consider the load of 1000 Newton. So first case, when the load P is acting, when the load P acting, P is nothing but 1000 Newton acting. Okay, so what are the vertical forces? First we will resolve by taking the vertical forces. So this is a one force, normal force, that is N, upward direction, and 2500 downward direction. So minus 2500. Okay, so there is a one more force. What is that? It is the inclined force. So same force you can split into vertical and also the horizontal. If this force, if you split into vertically, then it will be 1000 sine 30 degree. If the same force, if you split into horizontally, then it will be 1000 cos 30 degree, and direction it will be upward, and this will be towards the right side. So this is upward is nothing but it will be taken as plus. Okay, so this will be taken as plus 1000 sine 30 degree. Okay, so these are the forces is equal to 0, where sigma V is equal to 0. Now let me calculate what will be the reaction force, that is N. So 1000 sine 30 degree minus 2500. So we will get minus 2000. So N minus 2000. If you take the minus 2000 into right side, you will get plus 2000 Newton. So this is the reaction force, also you can say, or normal force, and will get. So now you know the coefficient of friction, that is the frictional force. So frictional force we will write F. F is the frictional force, that is equal to mu into N. So mu is the coefficient of friction, that is given in the question, 0.20 into the N is the reaction force 2000, you just calculated, that is equal to, so 0.20 into 2000. So we obtain 400 Newton is the frictional force. So this is 400 Newton. Okay, so after that, so there will be the initial velocity and there will be final velocity. We have to define now. Let the final velocity will say V will be the final velocity, and S is the displacement, as already we have mentioned, that is 30 meter. Okay, now apply the work energy equation for the horizontal motion. Okay, so for this horizontal motion we will apply the work energy method. So work energy method, you should know the equation. What is that? Where the work done is equal to the kinetic energy. Work done is equal to kinetic energy. So what is work done here? That is the force into the distance. Okay, the force applied into the distance traveled in the applied forces is equal to kinetic energy, that is half mv square. Okay, so in a equation it is there, I will write down in the form of values. So R into S, this will be S, that is equal to half, m is nothing but load by gravity, is equal to the velocity. So here we have the initial and final velocity. In that case we can write the kinetic final velocity minus kinetic initial velocity. So v square minus u square. So here where R is the horizontal forces. So what are the horizontal forces? Let me check now. So one is 1000, it is acting towards the right side. So that will be plus value. So plus 1000 cos 30 degree, one force, and another force, that is the frictional force. So that is acting towards the left side. So that will be taken as minus 400. Okay, so these two are the horizontal forces. Now into the distance, S is nothing but the distance, that is given as 30. So is equal to 1/2 into load, applied load is 200 the weight of the object divided by 2500 divided by g is nothing but the gravity 9.81 into v square. V is the final velocity which you already defined. Okay, so v square will write minus u square is nothing but that is the initial velocity. So when it is in the question it is mentioned when the object is in the rest. So rest is nothing but there the initial velocity is 0. Okay, so now in this equation v is the unknown. So from the simplification of this equation you will get the value of v. Okay, so I obtained v as 10.4745 meter per second. This is the velocity value. Okay, now you can calculate from this equation. So this is the value you will get. So later we will go to calc by considering the absence of the load 1000 Newton. Okay, now in the second case when it is removed, the load 1000 Newton is removed. Okay, so this is the second case you have to consider now. So first, okay, so in this case now when the load is removed, this load is removed, when a object how long it can move forward and what will be the velocity they are asking now. Okay, so what will be the initial velocity when the load is removed? So initial velocity, it will be the final velocity now. Okay, so when the load is immediately removed, so that will be the your initial velocity. So v we can take. Okay, so we can take, sorry, u you can take as the final velocity now, that is given as that we have calculated as 10.48 will write meter per second is the initial velocity. Now the final velocity that will be 0. Okay, now again let me go for the work done energy equation. Okay, so that is W into D is equal to kinetic energy. Same equation you write down, R into D. Okay, so R is nothing but the force. Okay, so R is the force or it may be a frictional force. Okay, R into S is equal to half M is nothing but W by G, again V square minus U square. Okay, so here in this case when the load is removed, so we are not considering this 1000 in either in horizontal or vertically. So what is the remaining load? When you will take the horizontal, only one force, that is the frictional force is acting. Okay, so that is frictional force along the plane we are doing, right? So this is the only one force it will be remaining, so that is acting towards left side, so it will be taken as minus because left side. So 400 frictional force into the distance. What will be the distance? S. Okay, what will be the distance? S you need to calculate. Half into W is again 2500 divided by 9.81 into V square is 0, U is 10.48 square. Okay, so now from this equation you will get the S. Okay, let me check the value. What will be the value? So 2500 into 10.48 square divided by 2 into 9.81. So we will get 13,994.69. It means 69. Okay, you can take directly 7 also. Where it is minus 400 again. Okay, so now this again minus it will be because 0 minus this value is there, so we will get minus minus. So this minus minus will get cancelled. So where S is equal to, we will obtain divided by 400. So we will obtain around wait 1 second. So 34.98 is the distance will be traveled when the load is removed. Okay, so this is the solution for the given problem. So thank you guys.